Good evening and welcome to our evening about Mars. My name is David Newland and I, for my sins, chair the Cairngorms astronomy group. Sam is waiting outside the dark sky park, getting the weather ready and getting the telescope ready in the hope that we're going to give you some live views of Mars in a little while. But first of all, I would like to introduce Mars, the planet itself. So here we are in the Cairngorms Dark Sky Park, and Mars has been called the Red Planet and has fascinated people for literally centuries. The name that we're familiar with is named after the Roman god of war, Mars. But of course, the folks in the north of Scotland knew him by a different name. To them, this planet represented their champion Ogmus, and they called it Goak. The first people to have a good look at Mars and make some drawings of it were the Dutch astronomer Christiaan Huygens. And he actually drew 3 pictures of it that you can see in front of you. And I hope that we can improve on the Christian's drawings a little while during the evening. But remember, this is the first view made in 1659. A little later, an Italian astronomer called Giovanni Schiaparelli made some maps of Mars. And as he stared at Mars for longer and longer through his telescope, he began to think that it was completely covered in canals. So he drew this rather fetching picture in 1877 that showed all sorts of waterways linking up various places on Mars. And he was also of the opinion, I believe, that the dark patches that we see on Mars might well be vegetation. So it was full of Martians and they were doing all sorts of interesting things. And the idea caught on because what happened was a little bit later in 1896, an Englishman, Percival Lowell, heavily influenced by Schiaparelli, produced even more detailed canal maps, and it was all the rage for quite a while until some people made some rather bigger and better telescopes, and the whole thing vaporized like Scotch mist. And they decided that canals didn't exist because once you got a really good telescope, you couldn't see them. They were just being completely made up all the way along. Meanwhile, H.G. Wells had been writing his classic novel, The War of the Worlds, in which he postulated that Martian was fully inhabited by intelligent beings, and they had a problem up on Mars, and they needed a new world. So they were coming down to Earth to take over our planet because for somewhere to live. And things started to look pretty nasty until some microorganisms, or was it viruses, got the better of them, and they all died in a rather nasty and sudden way towards the end of the book. But the debate over life on Mars has continued ever since. And we'll return to that subject later on this evening. Now, why are we looking at it tonight? Well, the reason is it's opposition. Well, what is opposition, you ask? Well, it's when we get really close to the planet. And those of you who've been assiduously looking up at the sky recently might have noticed that Mars has been getting bigger and brighter in the sky. In fact, it's about the brightest twinkly thing that we've got up there at the moment. On this chart in front of you, I've got 2 orbits just to make it really simple. So on the outside orbit, we've got Mars going around the sun there. And on the inside orbit, we've got the Earth going around there now. The Earth actually, because it's close to the sun, goes around quite a lot faster than Mars. In fact, it goes around almost twice as fast. So what's been happening over the last few months is we started off in the spring, Mars was around here and we were well behind it. And as Mars has been going on its way towards October the 7th, we've been catching it up. In fact, today we're overtaking it on the inside lane. So we're getting about as close as we possibly can be to Mars, which gives us our best view of it. Now, on Opposition, we can actually get as close as 33.9 million miles. Whereas at conjunction, we're as far away as we can get. We could be as far away as 250 million miles. And this chart I've got here just gives you an idea of how things have been going recently. So over on the left, that was March, and 19th of March, when it was pretty small, and gradually through May and June, we got closer and closer as we were catching it up. And on July the 7th, it was getting pretty big, but all of a sudden, by the 6th of October, it was as big as it was going to get. And from here on, it'll get smaller and smaller and smaller and smaller. So we thought tonight was a special night. And in fact, we planned this 4 years ago when we started the Dark Sky Park project in Tomintoul and Glenlivet. And here we are, we've got to the point where we can have a good look at Mars. So what I'd like to do now is to hand over to Sam. Are you there somewhere, Sam?
Yes, I am. If you can hear me, I'm just going to put the video on now.
So I need to stop sharing my screen. It's all very technical.
Right. Okay. If everybody can hear me, I've actually got Mars in the field of view of the camera on our telescope. It's not in the best position. It's quite close to the horizon, so I'm not going to be able to show you a particularly good image of Mars. But let's see what we can do here. And right, we should now be this pink blob that you're seeing in the middle of the screen. I'm afraid I can't really get it much sharper than that because, as I say, Mars is extremely low, far down at the moment. It's quite close to the horizon. But I do have some video that I took last night when Mars was much higher up in the sky. So if I stop this and then switch to what we had last night, I might be able to see what we and I think we can take this back to just mess around a wee bit here. If I just do that, we can now see a larger image of Mars. You can see a dark region down here, down the middle of the band here. This is the North Pole of Mars up here, with the South Pole down below. And what you're seeing in the bright regions, the pink regions, are the dusty regions of Mars. High content of iron oxide, that's just the same as rust. So you could call it a rusty planet. And the dark regions are volcanic plains of dark basaltic rock. But this is where the seasonal winds of Mars have blown away the dust, allowing you to see the dark plains underneath. I could also share here as well. I've got a picture, a frame that I took from it that shows it in a bit more detail. So if I just find another thing to share. Get this to work. There we are. That was a view from last night. It's been enhanced quite a bit in the computer, but we can see this the two halves of Mars, as it were, the dark half, the southern half. This is south at the top because that is the normal way that you would view through an astronomical telescope. It's traditional to have south at the top. This here is the northern hemisphere, which is largely covered in dust. And this feature we're seeing here in the middle is called the Mare Cimmerium. Mare meaning sea, because some of the early telescopic observers back in the 18th century and even earlier interpreted these dark markings as being oceans. This feature here is the Syrtis Minor, and this little light-coloured bay in here is known as Hesperia. A lot of these names are no longer used anymore. These are all what are called albedo names, where albedo means the the reflectivity of the planet, how bright it is or how dark it is. And in this case, because people in the past thought that these might be oceans or the like, they gave them some quite romantic names. And we have names like Phytontis and Amazonas and the like. So it's quite romantic names, but these are not generally used anymore. And now that we have images from passing spacecraft and indeed orbiting spacecraft and rovers on the surface. So with that, I'll just hand you back to David now, and he can carry on with some rather sharper pictures of Mars taken by some of these space probes.
Right, I'm going to let you keep answering the questions. We've got 2 more questions on there, which you're probably well qualified to answer. I will just carry on and show you what you would normally expect to see on a good evening looking at Mars at opposition. And by the good time, you would be better off looking at midnight when it's much higher in the sky, because at the moment, it being down near the horizon, we're looking through a huge amount of atmosphere. So it's pretty muggy to be looking at, but later on in the night, it will look quite a lot better through a telescope. So Mars is the 4th planet from the Sun, and it's only half the diameter of the Earth, so it's quite a lot smaller than us. And the fact that it's only half the diameter of the Earth explains quite a lot of things about Mars, which we will learn about a little bit later on. The distinctive red colour is due to iron oxides. And when we look at it, as normally in the telescope, it's the wrong way up, with the South Pole at the top. But I've got to turn this the right way up. So we've got the South Pole at the bottom. And just going through some of the other features, southern polar ice cap, not really water, but mainly frozen carbon dioxide. Whether or not you actually see it depends on the season. So at the moment, with it being summer in the southern hemisphere on Mars, there's not a lot of the southern polar ice cap to be seen. The next most obvious feature is Syrtis Major, which actually wasn't turned towards us on Sam's pictures the other night, but a lot later on tonight, we're talking about 2 or 3 o'clock in the morning, then it will be facing us, and it will be one of the most obvious markings on the planet. Syrtis Major is a massive shield volcano. It's about 1,000 kilometers in diameter, and the reason it looks dark on the surface of the planet is because of the basalt volcanic rock and a relative absence of dust in that area. Below it, a nice bright red circular colour is the Hellas Basin, which is an impact crater. It's one of the largest impact craters in the solar system. It was formed around 4 billion years ago when a protoplanet hit Mars. Just think about that. I mean, if it had been much bigger, it might have split the planet in half, and we might not be looking at Mars at the moment. What a thought. Mars has got some moons. They're not very big. And this is courtesy of the Hubble Space Telescope, because over here we've got Phobos, which is named after the Greek for fear, orbiting the planet. So Mars has got 2 small moons called Phobos and Deimos, Fear and Dread, which is fairly appropriate for Mars, the god of war. They're probably both captured asteroids, which will explain their rather peculiar shape and other characteristics. So taking Phobos first, it orbits only 6,000 kilometers above the Martian surface. That's really, really close. Taking just about a quarter of a Martian day to go around the planet. So that's about 8 hours. So because it's going faster than the planet is itself, it rises in the west and it sets in the east, which is the opposite of what happens here with our moon. Because it's so close, we think that eventually it will spiral into Mars and crash onto the surface. so it's going to come to a bad end. Moving on to Deimos, this orbit's about 20,000 kilometers above the Martian surface, quite a lot slower than Phobos, takes about 30 hours to go around the planet. That's about 2.5 Martian days between rising and setting. A lot shorter, of course, than our moon takes to go around the Earth. And so, because its orbital period is only a little bit longer than the Martian day, it actually stays in the sky for 2.5 days before it sets after it's risen. So very odd behavior from both of those planets. Moving on to conditions on Mars. Well, you might think it was all right looking at the headline. The day length is about similar to here on Earth, 24 hours, 37 minutes. The year length is a bit longer, 687 days, so twice as long. The radius is a lot smaller, about half that of Earth at 3,390 kilometers. So it's all good news because the gravity is only 38% of Earth. So if you fancy taking some strenuous exercise, you're going to be able to run and jump, etc., lots faster up there than we can down here. And if you're lucky, the temperature, the daytime temperature, could be up to 35 degrees centigrade. But the situation doesn't improve. There are also bad points. The bad point is the night temperatures go down as low as minus 143 degrees centigrade. So you really need to wrap up warm at night. The reason it gets so cold is partly because it is a lot further from the sun than we are. And to go with those bone-chilling temperatures, it's got dust storms which can be up to 160 kilometers an hour. In fact, these dust storms can be so huge that they can last for months and almost envelop the entire planet. Now to the ugly. That's the atmosphere. Don't bother about the atmosphere because basically it's not got any. The pressure is about 0.6 the atmospheric pressure of Earth. And because it's 96% carbon dioxide, 2% nitrogen, 2% argon, with only traces of oxygen and water, if there was plenty of it, it wasn't going to be worth breathing anyway. So if you go to Mars, you are going to need to take something to breathe with you. Before we have a look at the exploration of Mars, I'm going to take a look at how you would get there if you're bold enough to be considering signing up for the first Martian mission. So here we've got some planets around the sun, and Mars is the red one out here. And as before, Earth is the one just on the inside orbit. And just to complete the picture, we've got some inner planets. This is Venus and this is Mercury. So here we are, all merrily going around the sun. Mars going a lot slower than we are, so we catch it up. So if we want to land on Mars when we get there, we need to take off from here so that we can make the journey, which could be anything from a couple of months up to a couple of years, depending when you choose your timing. So that is the way that one normally goes to Mars. The first one that I'm going to talk about, because I'm going to just give you a selective few, because Mars is actually littered with a history of failed spacecraft which have crashed or been lost or done all sorts of disastrous things. But I'm going to start us off on Mariner 9, which was an orbiter. And Mariner 9 really added to our knowledge of Mars because it identified some high altitude volcanoes. This is Olympus Mons, which is nearly 3 times bigger than Earth's largest volcano. It's the largest volcano in the solar system, and it is actually 26 kilometers high, so absolutely massive. The other huge feature that the Mariner spacecraft discovered was named after it, the Valles Marineris. And it's a canyon, basically. It's a canyon that is one of the biggest ones in the solar system. It's 4,000 kilometers long, 10 kilometers deep, and 200 kilometers wide. Nearly 10 times as big as the Grand Canyon. So the Mariner spacecraft, Mariner 9, was able to add significantly to our knowledge of the planet. Moving on to the next orbiters, the next successful orbiters sent out in 1976 were the Viking Orbiters. And these actually revealed there were many craters on the surface of the planet. And what that suggests that the planet has been dormant for a long, long time. On Earth, craters can't last for very, very long because they soon get eroded away by wind or by the sea or by plate tectonic activity. But with all these craters on the surface of Mars, it became fairly obvious that there wasn't a lot of surface activity anymore on Mars. And the other thing that was very interesting that was picked up by the Viking Orbiters in 1976, was the fact that there were dried watercourses. So although Mars may be a terrifically cold and inhospitable place right now, it seemed that way back in history, there was actually running water on the surface. So moving on to the first landings, both of the Viking Orbiters carried landers so that they could explore the surface. And Viking 1 mission, I'll tell you a little bit about it, landed at a place called Planitia on July 6, 1976.
Yeah, I think that is Mars.
It made the first ground measurements of Martian weather.
I have a quick look at my...
You want to break in there, Sam, and show us something?
Oh, sorry, no, it's all right. I was having a conversation offline there. I think I'll just mute my microphone at the moment.
Okay then. So Viking 1 made the first ground measurements of Martian weather, and it looked for organic chemistry, but didn't find anything convincing at all. This is where we head over to some maps which I'll be using of Mars, and I'll just take you through. So you see this arrow moving here. Olympus Mons over here, just above center left, that's that massive mountain. Just below it to the right, there's the Tharsis area, which I'll talk about a little bit more later, which also contains 3 volcanoes that have been spotted by Earthbound telescopes because of the clouds that gather around the tops of them. The place where Viking 1 landed was here at Planitia. And moving on to the other things we've talked about, at the Hellas Basin, one of the biggest craters in the solar system is down here. And it seems that the NASA didn't manage to put, what's the name of it, in here, that other large shield volcano that I talked about earlier. So moving on, the next spacecraft in there was basically a tryout. It was part of the Pathfinder mission, and it was sent out in 1997. And it was a little tiny rover that I think was barely more than ½ meter long. And it was out there to test what it was going to be like to explore Mars using essentially robotic devices. It landed in the Ares Valles region on July the 4th, and it was a lightweight proof of concept mission designed to demonstrate the rovers could actually be landed and operated. The onboard equipment included the camera, weather instruments, and a spectrometer for mineral analysis. Communication was lost after 85 days. So it didn't do too badly. So here's the map. It landed a little bit over to the right of where the Viking lander, Viking 1 had landed over here. Moving on to 2004, we come to a pair of rovers that were sent out at the same time, Spirit and Opportunity. This is Spirit, landed in Gusev Crater on April 1st, and the mission was planned to last 90 days, but it lasted for over 5 years, so it really did well. It found evidence that Mars was once much wetter than it is today, and it helped us to better understand Martian weather. After 5 years, in 2009, May, it became embedded in soft soil. At NASA, they persevered with it, but finally gave up 2 years later, and when they accepted they were never going to free it again. So Gusev Crater looks like this. This was the landing site, and the reason this was chosen was because it's situated, the crater is situated at the end of this valley, which seems to have once been flooded in the past. So that was why the landing sites for Spirit was chosen, because that was such an interesting place for it. If we move on to, no, I've got Spirit. This is the landing site, right over on the right here, almost on the opposite side of the planet, but still fairly central along the equator from the previous 2 landing sites. Heading on to Opportunity, which was, I know it looks a bit different, but it was a pretty similar beast. I think they were almost identical. This landed at Meridiani Planum on April 25th. The planned 90-day mission actually lasted almost 15 years in this case, and the rover itself traveled more than 45 kilometers. Just a little aside there, you don't want to rush around when you're on the surface of Mars, because there's all these rocks, and if you tripped over one and you turn the rover over, your mission would be stuffed for the rest of the thing. So these tend to move very, very slowly, taking a lot of care, and as well as not wanting to compromise themselves, they find a huge amount of interesting stuff to look at on the way through. In fact, Opportunity discovered evidence that Mars may once have been able to sustain microbial life. It ended after its 15 years after a severe sandstorm blanketed the rover. This was its landing site. It looks pretty featureless. And if we carry on to update our map, it was over here. So Spirit was over here on the right, and this is Opportunity, quite close to where Viking and Sojourner had their little trips. Close to the Valles Marineris and the Tharsis area. Now, this is a picture of one of the really interesting things that Opportunity took a picture of. These have been christened blueberries. In fact, they're hematite mineral concretions, and since they can only form in a water environment, they added to the weight of evidence that was building about Mars previously having a lot more water than it's got at the moment. So we come on to the real star of exploration, which is Curiosity. It went down in 2012 and it's still going. It landed at Gale Crater, and the mission was planned to last for 2 years. So far it's been going for 8. Its mission was to provide a more detailed history of Martian climate and geology, and to assess whether Gale Crater had ever got the conditions favorable for microbial life. As of 2020, it's alive and well and exploring Mars right now. So this is where it landed. Aeolis Palus, just about in this area, and that is next to Olympus Mons, otherwise known as Mount Sharp and Gale Crater. So it got some huge wealth of pictures, and if you're interested, do go and have a look online. Its landing spot was over here near where Spirit was, again in the central part of the planet. And here's one of the really interesting pictures it took. This is an example of a cross-bedding structure. Can you see that in the lower part of this rock, the sediments run in that direction from lower left to upper right, whereas in the top, they just run across. Now, on Earth, structures like that form in rocks when the water passes over a loose bed of sediment. And these particular examples were probably formed as currents moved down from deltas on lower Mount Sharp into deeper lake water in Gale Crater. Moving on, when this is Curiosity gaining a bit of higher ground on the side of Mount Sharp, looking back down, and you can see these fantastically extensive layers of sedimentary rocks. And in the middle ground down here, there are clay-bearing units. So much finer sediments than the former sandstones. And the floor of Gale Crater, which was at the bottom of once a lake, is over here in the distance. So, what have we learned about early Martian history from all these orbiters and landers and rovers? It's an interesting story. The early Mars, as is common with most of the planets in the solar system, look like hell. It's a great big molten ball of molten rock, experiencing a very high rate of comets and asteroid impacts. And all of that formed a pretty dense atmosphere because of what the comets brought in with them, and because of outgassing, that's gases being given out by this red hot volcanic activity in the protoplanet. And that had the effect of forming a really dense atmosphere. And at this stage in the planet's life, the Vastus Borealis was formed, which was the northern side of the planet, which has got a lower altitude than the southern part of the planet. And as the planet cooled, the water vapor condensed into a vast ocean in that Vastus Borealis area. And in that ocean, it is quite possible that life may have emerged. Moving on to 4.1 to 3.7 billion years ago, that's what these funny little figures are up in the left-hand corner, a long, long time ago. It may well be that if there was life on Mars, it could have well have started before it started on Earth. This is called the Noachian era. And that is characteristically had a massive amount of volcanic activity that's pouring ash and gases into the atmosphere, and heavy bombardment is continued by comets and asteroids. As the planet continued to cool, rain was able to fall to ground level. Beforehand, it couldn't because it simply boiled off before it got anywhere close to ground level. And we believe that was the stage at which lakes formed in basins and craters, which have been nicely illustrated just down here. At this point, the Tharsis Bulge was created by the volcanic activity, and the Valles Marineris, that huge canyon, formed after widespread fracturing of the planet's surface under the influence of the volcanic activity. Also, at this time, the Hellas and the Isidis and Argyre basins were formed, which were impact craters, but later filled with water to form huge lakes. So moving on, 3.7 down to 2.9 billion years. Huge amounts of sulfur dioxide and water was still being ejected from volcanoes and at least 30% of the planet was resurfaced. But the amount of asteroid and comet activity in the solar system was declining at that point, and we see less evidence of it on the surface of Mars. The climate continued to cool, and as it got colder and colder, so the water became locked up as ice and permafrost. This is a picture of the North Pole of Mars in winter, showing you what it looks like these days. And at the same time as the water became locked up as ice and permafrost, the valley network formations I showed you earlier on declined, because without running water, you're not likely to get many more valleys forming. We move on to the most recent period of Martian history, called the Amazonian, which is from 2.9 billion years to the present. And during this period, wind erosion and deposition reshaped large parts of the planet's surface. The atmosphere became so thin that now water vaporizes instantly at the planet's surface, and surface alteration by anhydrous ferric oxides, that's the lack of water in those ferric oxides, are what finally gave the red planet its color. So moving on to future missions, because there's a lot of excitement, and it's not only the Americans that are involved, but we'll start with the Americans. Perseverance is another rover, state-of-the-art one, that's due to arrive on Mars in February next year. And it's a rover to study the surface geology and processes and the habitability of Mars, I think in preparation for when we send the less useful members of the political establishment to go and live on Mars to see what it's like. The Emirates, the Arabs, are also sending out a Mars mission, which will arrive in February 2021. There's an orbiter, and that orbiter is designed to study the daily and seasonal weather cycles. A little bit later on in the year, in April, then there's a Chinese Tianwen-1 will arrive on Mars, and that is going to look for biomolecules and biosignatures. So although we've seen that we've got a lot of evidence that life may well once have been present on Mars, we still need to look for the killer evidence of the actual signature of life on the planet. So I hope you found tonight both interesting and enjoyable, and thank you for watching. And if you have any questions, then please try Sam and me, and we'll try answering them.
Okay, I think that I think I've answered most of the questions by typed answers, but I think Eric was wanting to see a picture that showed retrograde motion. So if I just share my screen here, I can. I've managed to lift one from. Right, David. I think you're sharing. So if you start.
I'll share. Okay, there we go. There you go.
Righto. Okay. I just have a picture here from Wikipedia actually, but can you see that, Eric? That shows the effect of one planet overtaking another, and then the effect it has on the planet's apparent position in the sky. But there are many diagrams. This was originally explained by the means of a very convoluted concept of epicycles. It can be much more simply explained if you assume that the sun is at the center of the solar system rather than the Earth. But it was also explained to an extent by Aristarchus of Samos way back in about 300 BC or 200 BC, who was actually the originator of the heliocentric system, but his name and his achievements were forgotten by history. So it took well over 1,000 years, if not about 1,500 years, for it to be rediscovered by Copernicus. Right, back to you, David.
Any more questions? I think early on, Rich asked whether Mars could have sustained advanced life forms, and I've studiously avoided watching that, answering that one. And I think the answer has to be that is fairly unlikely.
Yeah,
because otherwise we would have seen some sort of evidence already. What we're looking for on Mars is basically microbial life.
Yeah, I think given the fact that it took almost 4 billion years for multicellular life, i.e. life with arms and legs and wriggly bits to form on the Earth, I think the chances of advanced life on Mars would be very, very unlikely, given that I think Mars only had a few 100 million years of a wet climate before it lost its water.
Yeah, it simply wouldn't have had time. Did you deal with the full optical setup? Do you want to just say what that is, Sam?
Yeah, just the setup is essentially it's just a Celestron C8 telescope with an ATIC camera on the end. Tonight, I was trying to put the Barlow lens on to magnify the image 2 times, but because Mars is so low, there's not really any great advantage. It would just appear even fuzzier. So I just stuck with the with not having the Barlow. But the pictures that I showed earlier on from last night, when Mars was much higher up and the atmosphere was much steadier, was with a Barlow lens to get a degree of magnification.
If I can pick up on Phobos and crashing into Mars, I believe there's a school of thought that says rather than actually hit the surface, it may be changed into a little ring.
Yes, that's the. I think that by the time Phobos gets much closer to Mars, it will be torn apart basically by Mars's gravity. Mars's gravity will be stronger than Phobos's binding energy.
What that is about is a thing called the Roche limit. When a orbiting body gets within a certain distance from the body it's orbiting, then, as Sam says, the cohesive forces within that body are broken apart by the planet's gravity. And that's really what has got those lovely rings of Saturn in place and keeps them like that. And I think there's now a school of thought that suggests that the rings of Saturn are actually quite new and they're always getting recycled. So whose turn is it next? Enceladus or some moon like that to get cracked up when the current rings disappear.
Right. To answer, I'll just answer. Eric is asking whether I'm on Wi-Fi or 4G. I'm actually on a cable. I've luckily my router is right beside the window, so I've actually got an Ethernet cable connected to the computer.
Yeah, best way of doing it, Ethernet.
Right. Any more questions? We got anything else they would like to questions they'd like to ask?
We can do our best on them.
Yes, we'll
can try.
We'll just make it up.
Hello?
Excuse me, I'll just mute this for a. That's okay. It was just it was my daughter phoning my wife. It's I had the phone out because everybody was desperate to get your phone number earlier on so that you could join as a panelist. So
have we got a club YouTube channel? Not right at the moment, but it's pretty well at the top of the list. For something we'll do. We're hoping we can we'll find quite a lot more things to do in the future. What have we got next? Traditionally, we've hosted these in the village halls in Dark Sky Park. And as we go into the future, that's not possible because of the COVID virus at the moment. So we're looking at shooting stars and comet dust on Friday the 4th December. And then we're moving on to Bronze Age star gazers on the 1st of February next year. And we've actually got a program for the next 2 years. And all of those will go onto a YouTube video site. And hopefully we'll find a way of having a live webinars as well. So if there are no more questions, I think we'll probably wrap this up for the evening, unless you've got another view of Mars to finish us off with, Sam.
I think it's actually much the same. Let me just
all right.
First of all, no, I don't, because there's clouds in front of it, unfortunately. It's
there we go.
going all the time, but it's really it's a shame it's so low down. But I will try and get some more in the coming week. I'll try and get some more video when it's high up around midnight, and perhaps with a different some different features on the surface.
Right, well, thank you all very much for attending. I hope you found it interesting, and we'll look forward to seeing you again.